Class TV. This will be the last episode of the topic elasticity. If you've been following us, I think you will have gained a lot. And also try to master our example. Now, this example is very, very important, mostly for us to prepare our mind against WAEC examination. Now, a stone of mass 2 grams is released. A stone of mass 2 grams is released from a catapult whose rubber has been stretched through 4 centimeters. Solution: a stone of mass, now we are given our mass now, m as 2 grams, is released from a catapult whose rubber has been stretched through 4 centimeters. That means the extension is 4 centimeters. Now something happens in this question. Now this question now is talking about how elastic energy of a catapult, when it is stretched, is being converted to what? To set a stone on motion. And that is telling us about what? Energy possessed by virtue, energy possessed by a body by virtue of its what? Motion, which is what? Kinetic energy. Now this is showing us how elastic energy is converted to what? To kinetic energy. Like, you know that one energy can neither be destroyed, be created nor what? Destroyed, but can be converted from one form to another. So we are given our mass here as 2 grams. Note, we need to convert this SI unit for mass is what? Is kilogram, which means that we need to convert this 2 grams to what? To kilogram, by saying 2 over what? 1000. 2 over 1000 now will give us what? 0.002 kilogram. Now our extension is given is 4 centimeters, so that will be what? 4 centimeters. We're doing that over time. Converting centimeter to meter will be what? Divided by 100, which is what? 0.04 meters. Now let's continue. If the force constant, now that is our K, if the force constant here is what? Is 200 Newton per meter. That's this, 200 Newton per meter. That's the force constant. Now we have to calculate the velocity of the stone when it leaves what? The catapult. The velocity of the stone when it leaves the catapult. That is what? V. Now I said elastic energy is converted to what? To kinetic energy, which means you can see that what? Elastic energy is also equal to what? Equal to kinetic energy. Under conservation of energy, kinetic energy. Now we have to recall that we said that formula for elastic energy is what? Is half Ke squared, 1 over 2 Ke squared. We use this when we were given elastic constant, and instead of what? Instead of force. So in this case, we are given elastic constant, so we use half Ke squared. We've proven that to us. Now, while kinetic energy, you can recall, kinetic energy is given as what? 1, that's half mv squared. That's formula for kinetic energy. Now let's substitute for the givens now. So we say this will be 1 over 2 multiplied by, what's our K? Our K is 200. Is 200 times E. What's our E? Our E is 0.04 meters, that's square, equals 1 over 2. Our mass is 0.002 kilogram, and this is the unknown, V square. So on this note now, you can say that what? You can say that 2 here, 2 here is 100. And we can also say that this one too goes like this. 2 here, 2 here will give us 0.001. 0.001. Okay? Let me squeeze the remaining here. Manage the board. So now, from the left hand side now, we are having 100 times 0.04 squared. That's 100. The 0.04 square now will give us 0.0 4 square will give us 0.0016. 0.0016 now equals to 0.001 multiplied by v square. That's 0.001 v square divided through by 0.001 now. So we have this 0.001, 0.001. This cancels this now. So we have v square equals what? 0. That's 100 times 0.0016 over 0.001. Okay, let's punch our calculator for that. 0.0016 multiplied by 100. That will give us 0.16 divided by 0.001, and that gives us 0.001. I think that should give us 16. That gives us 16. That gives us 16. We press 0, so we have v square equals what? 16. Root both sides. Root both sides. This cancels this. So our v is equals to what? Square root of 16, which means the velocity is equals to what? 4 meter per second. That's unit for what? Velocity. So that gives the final answer for the question. We have to find velocity. So our final answer is what? 4 meter per second as velocity. Now let's take the next question. It said an elastic string of 20 centimeter extends to 24 centimeter. Now in this case, now we are given the original length. Now let me call it L1 as 20 centimeter. Now when it extends to 24 centimeter. That means L2, that's the new length, 24 centimeter. Now with this, now it shows that what our E, which is the extension now, is L2 minus L1, which is what? 24 centimeter minus 20 centimeter. Now which it means that what our extension is what? Is 4 centimeter. Now so with this, now we can now convert our extension, which is 4 centimeter, to what? To meter. So that will be 4 divided by 100, which will give us what? 0.04 meters. So that's the extension. The next one, they said, okay, when it supports a weight of 50 Newton, that means our force is 50 Newton. Now we are told to find the what? The energy stored. Energy stored, in this case, energy stored has two formula, which is elastic energy. It has two formula. We said either we use half ke square or we use half fe square. In this case, now we are using half fe square because we are given the extension and what? The force applied. So we are using 1/2 fe, and that's 1/2 times 50 times 0.04. 2 here 1, 2 here 25. So which means we are having 25 times 0.04. That's 25 times 0.04 should give us what? 1. That's 1 joule. 1 joule. So that's the final answer for that, 1 joule.